we are finally on the last set of stuff for 213. It's going on page 76 when we're done. Lots of important words up here, okay? On the AP pre-calculus exam, FRQ4. So there's 4 FRQs. There's 4 of them. And the nice thing about our FRQs is that their FRQ4 is going to be formatted exactly the same every year. FRQ3 is formatted the same. Obviously, I don't know exactly what the question is or even exactly if it's going to be quadratic or linear or whatever, but I know what types of things. So, but on FRQ4, one of the things that it will require students to solve various logarithmic and exponential functions without the use of a calculator, okay? And this right here is part of the directions that you will see at the top of FRQ4. I didn't put them all on here because it's not necessary right now, but this stuff is important. No calculator allowed, obviously, just said that. It says determine the exact value of any expression that can be obtained without a calculator. And that also means not just exact, but it has to be reduced all the way. So day before yesterday, our last example, if you did it differently than I did, which most of you started off and did it differently than I did, and that was okay, but you ended up with actually a log base 2 of 8 in there, and you weren't wrong, you just weren't finished. So you have to know that log base 2 of 8 can be written as 3. If you got log base 2 of 7, nothing you can do about it, it's log base 2 of 7. It's like if it's a square root of 4, you put 2. If it's a square root of 5, you leave it square root of 5, right? You reduce it if you can. And so things like that are not always as obvious to y'all that it's not reduced. If you have 4/8, I think you know you need to reduce it to 1/2. That should be obvious to you at this point. That may not be as obvious. And then also combining like terms. And some of these I think are obvious too. 2x plus 3x plus 5x. 5 squared times 5 cubed, 5 to the 5th. You'd get x cubed here. But then this one, even though you know what to do, I don't know that it's necessarily as obvious to you that it is not reduced all the way or not simplified all the way. I have 2 logs with the same base, and they're being added, so that means I can change it to 1 log, and this would be the natural log of what? 15, because I'd multiply, okay? And just because you haven't done that as much, I know you know the rule, but you may not think of it as not being combined, finished, and you got to make sure you put it all together, okay? By the instructions. I got it. All right. So you have way more than enough room to write on this stuff because I'm actually going to do both of these questions 2 different ways because I just want you to see how you can handle it differently and how your answers might look different. So there's tons of extra room. If you mess up on anything, you can just mark it out. You don't even have to bother erasing because I figured if I had the room, I'd just give it to you. It'll be fine. Alrighty, so here we go. We've got, here's f of x, and it says solve f of x equals e to the 1/2 for all values of x in the domain of f. Does that mean I take this e to the 1/2 and plug it in where x is? No, because it clearly says f of x equals this. However, some of y'all would totally plug that in for x. You need to make sure you understand why that makes absolutely no sense, right? It does not say x equals that. So that means I'm just going to set these equal to each other. So I'm going to have e to the x to the 5th power over e to the 1/4 equals e to the 1/2. Okay, and I will also tell you, okay, think about this. This is FRQ4. It'll be the very last thing you do on the exam. The exam is long. Your brain is tired. You are tired. And then you get stuff that looks like this. And they will look horrible. All of them will look horrible. It does not mean that they're difficult. And you have to remind yourself about that. Don't let it get into your head and don't let the ugliness win, right? Like just because it looks weird or bad doesn't mean that it's difficult. What would be the first thing you would like to probably tackle in this question? Yeah, the division, like get rid of the fraction, right? We try to do that. So I know I can do that by multiplying both sides. So I'm going to leave this left side as e to the x to the 5th power equals e to the 1/2 times e to the 1/4. Even though these may not be crazy difficult, they are ugly. They are going to use symbols and stuff that you're not necessarily as comfortable with as x. So don't be skipping steps here. You ain't got that. That's just going to make things worse. Also, only deal with one thing at a time. Notice how I left the numerator exactly like it is and just moved that over there. That is going to keep you, especially when it's late in the game, from hopefully making ridiculous mistakes. Baby steps through it so you don't do something stupid, okay? Which you know we're all capable of, myself probably more than most of you. All right, but now that I get this, On the right-hand side, does that become e to the 1/8? No, it does not. And I think that you know that. If I gave you x squared times x to the third, y'all would put x to the fifth. I would bet pretty good money on it. I throw an e in there and make them fractions, half y'all going to put 1/8, right? Because you just, that it was just what, I don't know. But you know the rules. You have to remind, it's the same rules you've been doing forever. If I multiply two terms with the same base, what do I do with the exponents? Add them. I'm going to, again, leave the left as e to the x. Is that like brand new news to you? Yeah. New news. All right. What is 1/2 plus 1/4? 3/4. You got to be able to add and subtract fractions. Okay. All right. So now that we're here, I'm going to pause here. I'm going to give y'all a minute to finish this up and find x. You can work together, ask each other questions, or do it on your own and then ask, but at least talk to people at your table. I'll go stand by this table and make them talk to each other. And give each other hints or ask what you're doing or say something, or I'm going to make all of you get up individually and give speeches at the front of the class if you can't talk to each other. At least talk to each other. So clearly I have to stand by this table too, right? Maybe. Well, what is it? So you cannot use the word it. Ooh. Yeah. Oh, I like those moments. Don't skip steps.
That's what I was saying. And then you said the exponents equal to each
other. Okay. We all pretty much have worked through it? No? Well, I'm moving on without y'all. Okay. So at this point, there's kind of a reason I left it like this before. I'm going to go ahead, I'm going to write down e to the 5x, because here I do get to multiply them, right? That equals e to the 3/4. If I need to get a variable out of an exponent, that means I have to introduce a log. Which log am I introducing? Natural log. So I'm going to take the natural log of both sides. On the left over here, this 5x gets to come out front. That pretty much goes away. I get 5x. That's equal to, same thing happens over here, 3/4. Okay? Then, the way I've seen most people finish this off, looks like this. But then I've had a lot of people all day get totally stuck on that or try to make up math. If at this point you are struggling, you better stop hating on pre-cal and start hating on 4th grade math and the fact that you still don't understand fractions. That is not a pre-cal concept, but you cannot get the correct answers if you don't understand fractions, okay? So I would suggest, especially if you have a fraction and like a whole number, make them both into fractions. And then remind yourself of what your division rules. Keep, change, flip. 3/4 times 1/5. That gives me 3/20. Now, instead of actually dividing when you have a fraction, you can also ask yourself, if I'm going to divide by 5, that is the same thing as multiplying by what? And it's always the reciprocal. So you could just start by multiplying by 1/5 right there and not go through all that other mess. But you have to have a concept of what's happening or you'll never think about doing that. Okay? We good? Questions? Well, let's just make sure. Sometimes we get lucky and y'all make up math, especially Nunu. Let's see. You basically got rid of the, oh no, that totally works. Yeah. Okay, now listen. So we're gonna start here, and I'm gonna go over here. We're gonna say or, okay, and I'm gonna rewrite what I have there. E to the x to the 5th power equals e to the 3/4. Now I started not even to do it this way too, because I really believe most of you, probably all of you, would probably work it like what's on the left, unless you were making up stuff and doing it wrong. But I do want you to at least see that this is a process. When in Algebra 2, when you started learning about rational exponents, so just so you know what I'm talking about, square root of x is the same as x to 1/2. X to the 1/2 power, that is a rational exponent. Make sense? Okay. So if I wanted to get that x by itself right there, then one thing I can do is take this to the 1/5 power, because 5 times 1/5, that's just 1, right? Which means I got to take this to the 1/5 power. So then e to the x is equal to, and I power to a power, so I multiply e to the 3/20. And then when I take the natural log of both sides, I get e, or x, equals 3/20. Okay.
So if you have it, an exponent to an exponent, you multiply it.
Mm-hmm. Power to a power, you multiply. You add them.
It.
It's brand new information, isn't it?
What about like the square root?
No. All right. Any questions on this? Are we good so far? Okay, so refocus, flip this over. Let's look at this one. There's only 2, which means you probably want to really pay attention. All right, so I've got my g of x, and here it says g of x equals 3e. What? Okay, so I'm going to set these equal to each other. 8 times e to the 3x power minus e equals 3e. Okay. Can I just drop the e's at this point? No. Can I take the natural log of both sides at this point? No, absolutely not. Can I combine these two terms?
No.
No, because they have different exponents, right? Can I combine this with something?
Yes.
The other side, right? And I'm not going to do anything weird. All I'm going to do is add it over there, because that's a basic algebra concept, right?
Yeah.
So this is going to leave me with 8e to the 3x equals 4e. Now can I take the natural log of both sides? No. There's just the 8 and the 4. Okay. All right, so listen, I need to divide. I can either divide by 4 or divide by 8. But remember, my goal is to get the x by itself, so I'd like to move as much away from that as I can. So I'm going to divide both sides by 8, so I get e to the 3x power equals 4e over 8. And then I'm going to make this e to the 3x power equals 1/2 e. Now, can I make that 1/2 an exponent on e? No, because that is a log property, right? That is not an exponent property. If, oh my gosh. Well, my goodness. Come on. There we go. All right, so if, let's talk about logs over here. If I have so my log property, if I have 1/2 times the log of 3, then that 1/2 can become an exponent on the 3, but that is a log property. So don't be trying to just make everything jump up into the exponent because you think that's a magic thing you can do now, all right? Only if it's a coefficient of a log. We good on that? All right, so back over here. So here then, can I take the natural log of both sides at this point? I can, okay? Now, is it just going to make everything disappear like before? No, and I can't drop, well, here's the thing, is I can't drop the e's like I did before, but I can take the natural log at this point. So I'm going to give you a minute. I want y'all to work on that. Find the answer.
So you move the 1/2 to.
One of these days, Nunu, my head's just going to explode all over you.
I hope one day you throw a book at him. Like, maybe we'll not.
I think I'll bring a water gun is what I'll do.
Like most of the times the other one would be equal, but in the reciprocal, yeah, but put it in the power.
Another way you could do this would be to change both ways to twos. I make this two to the power
No,
of
because
zero.
the exponent is not on there, so it really wouldn't help. Like, could you? Yes. Would that help you in this situation? No, because it's not the base of the exponent. Does that make sense? That helps you. Like, if you had 2 to the 3x and 8 to the 1/2 or something like that, then doing that if you want to get common bases. But I have common bases, so I don't need to do that. Does that help? That's a good question.
What if we raise it to the okay? If we raise it to the 3,
You got lots of room. You got lots of room. So if you mess up something, you can just mark it out. You don't even have to erase. And it's good to leave the wrong stuff on there. You got to know what's wrong to or what's not to do. It could not. I'm sorry. That is not the answer, but I've gotten that all day long, and we'll talk about it in just a second. Okay, I will tell you though, the answer is not 1/6, and it's not just a single fraction period. It's not a single fraction. This one literally just came out of my mouth.
3.1.
Oh my God.
Shut the hell up.
I'm close, but you're not done. Mm-hmm. What happened to your E's?
Yeah, what happened to them? I don't know. You dropped them because you put the natural on.
But you can't do
They can just go
what's the- Okay. All right, everybody focus up here. All right, ready? 1, 2, 3. Shh. Okay. I need to get the variable out of the exponent. I can't just drop anything because I have that coefficient of that 1/2, that kind of stuff. But I can take the log of both sides now. I guess technically I could have done it at some other step too, but like it just would have made things worse. But I isolated this the best I could. So now I'm going to take the natural log of both sides. Okay. Then when I do that over here, this gets to come out front, right? That essentially goes away. You're left with 3x. That's equal to the natural log of 1/2 e. The natural log of e on the right-hand side doesn't just make it disappear, because technically, remember, it's not disappearing. It is a property. There's no magic actually happening here. So I have this. But on the right-hand side here, I actually have 2 things being multiplied. So I can change that into natural log of 1/2, and then what? Plus natural log of e, right? That's how you split that up when things are being multiplied. Now, what is the natural log of e? 1. So this becomes 1. So that means that x equals natural log of 1/2 plus 1 over 3. Okay? What questions do you have at this point? Because I'm going to show you a different, listen, I'm going to show you a different approach, and your answer is going to look different, but they're going to have the same value. And that's important because if this was free response, depending on your instructions, this might be fine. But if it's multiple choice and you get this and none of your answer choices have a 1/2 in it, you're going to think you're completely wrong. Okay? And I don't want that to happen. So we're going to go over here and do an OR again. So I'm going to start here and OR. I will end up with e to the 3x power equals e over 2. Would you agree that e over 2 and 1/2 times e, those are the same thing, right? One's not necessarily better than the other. But if I start here and do my natural log of both sides, then over here I get 3x. On the right-hand side, now this is division, so this gives me the natural log of e minus the natural log of 2. I also think in that situation, you'd be less likely to try and make that 1/2 an exponent when it has no business doing that. Natural log of e is still 1. So x is equal to 1 minus the natural log of 2 all over 3. Okay. Now, I want you to look at these answers. I don't normally box my answers, but we're going to look at all these. These look completely different. They have the same value. On a free response, again, depending on your instructions, because it could say, write your answer as a fraction with subtraction in the numerator or with addition in the numerator, something like that. So that's why I'm saying, depending on the instructions and how specific they are, and sometimes they're specific. But let's say that it is multiple choice and you get this and there's no 1/2 and you're like, I don't even know, I guess I did it all wrong. Doesn't mean you did. I want you to see how you can manipulate this stuff. This, I can rewrite this as the natural log of 2. Well, 1/2 is 2 to what power? -1 power plus 1 over 3. So then this right here, that -1 does get to come out as an exponent, right? So he gets to come over there. I'm going to get negative natural log of 2 plus 1 over 3. That's why they are the exact same thing. And I'm going to show you one more thing with graphs as well here in just a second. Everybody okay with that? So essentially what this says is that negative natural log of 2 and natural log of 1/2 are the same thing. All right, well, let's think about the graphs. Natural log of 2 looks like that, right? Natural log of 1/2 looks like this. Okay, you agree with that? But negative natural log of 2 means we would take this and reflect it, and it would look like this. Because negative natural log of 2 and natural log of 1/2 are the same thing. And that's true really for all of your different log stuff. All right, questions? We good? Don't get intimidated by this stuff, but you know how you don't get freaked out about this stuff? When you actually do the work and work through these questions and think about what you're doing and practice them. If you never do any work on it, you're not going to be able to figure out how to do it. Okay? What questions do you have at this point? Anything? Okay, so that's it for today.